Okay, box and whisker plots as we move forward through Unit 2. Kind of neat stuff here. So if you look at, let's go to the class for a quick second here. Content, U2A5 box and whisker plots. Um, Kind of weird phrase there, especially when I butcher it, but that's looking at the spread of distribution. Okay, so we're gonna look at we're gonna construct one of these real quickly, and then we're going to talk about what they give you. Now, you have all the skills to make one of these now, and I'm not going to go through each step, but I'll tell you what you need to do. Make a couple, okay, and then we'll talk about what they look like when they look a little bit different like this, what that means, okay? So let's go over to your homework. So I downloaded your homework. Where is it? From the assignment, okay? And there are way too many questions here. You try a couple of these. Try like one here, one there, okay? Don't do too much of this. Make one or two so you really understand what's going on, and then spend your time under trying to figure out what the box and whisker plot tells you. Okay, so the first group of data. So I'm going to cheat a little bit. You're going to have to find the median. You're going to have to find the first quartile, and you're going to have to find the third quartile, the minimum value, the maximum value, and the interquartile range. So I'll get to all that in a second. So you go ahead and you figure out the median, okay, the way we've done it with the 50th percentile. Okay, in this case, for number one, it's 16. And you find out the first quartile is 14, and you find out that the third quartile is 24. So when you start to make this plot, first we start with the box. So the box is starting at 16. So here's a little scale from 10 to 30, and I'll talk more about this in a second, okay? So at 16, you put your median. So there's your median. Okay, so I'll just write this down here, median, okay? And you don't need to write median, but that's the middle of everything. Then you find out the first quartile, do all the work you need to do for that, okay? And that you put another line here, and then the third quartile, or the 75th percentile, is at 24. So there's 25 and there's 24 here, okay? And then what you do is you construct a box between the first quartile and the third quartile, which will encompass the median, which is in the 50th percentile, okay? So here's the first quartile, okay? So the Q1 and the Q3, not first quartile. Yeah, first, I'm sorry. Exactly, Q1 and Q3, okay? In the middle is the median, okay? So this is the 25th percentile, the 50th percentile, the 75th percentile. There's your box. And this is really easy. Then once you do all that work, then you find out the minimum value and the maximum value. And that's not too difficult. All that is the biggest number and the smallest number. So there's the smallest number. This is ordered. Here's the biggest number here. So your minimum is 12. Okay, so your minimum is 12. So right around here is 12. And what you do is you draw a little line from here to here. Okay, you don't make a big line here. You can put like a little end. And biggest was what, 27, I think? 27, which is here. Okay, so you get to 27 and you draw a little what they call the whisker here. Now you can put a little end part here. Sometimes I've seen them without ends, so sometimes they look like this, okay, with nothing. And sometimes you see them with like a little stopper. Just don't make this. Don't do this. Okay. So there's your box. There's your whisker. Okay. I think I might have said whisper at some point. What's that mean? What's going on here? Okay. This is a way to look at data and understand the spread of data. Okay. So here we have a situation where people are, whatever this is, some sort of score or something. The majority of people, okay, so half of the people are going to be in this area here between the first and third quartile, okay? So between the 25th percentile and the 75th percentile, this is where everyone is here, okay? And then you have these little pieces at the end, and they talk about the extremes, okay? So this is after the first quartile all the way to the beginning, and after the third quartile all the way to the end, okay? So the box shows you where most of the people are, the central, okay, between the 25th percentile and the 75th percentile. And then the little end parts show the extremes, okay? On some of the work, occasionally what you'll do is they'll show a little outlier over here. So what they'll do for the max or the min, let's look at it back at our data. Let's pretend we had a piece of data that was way bigger than 27. They'll throw it out of the data. They won't count it, okay? They won't use it for the median, the mode. Oh, sorry, they won't use it for the median or the first quartile or the third quartile calculations, and they'll just put a little box here saying, look, something weird happened, okay? And by weird, it's not all, I keep talking about test scores on exams, but when you look at data, a lot of times what the outlier is actually a calculation, problem. So what will happen is you measure the temperature of something. Okay, so over time you measure the temperature. So here's your temperature, and you measure the temperature, and you measure the temperature, and you measure the temperature, and all this stuff. And there's different things here, and the temperature's here, and you plot everything, and then you go, okay, that's normal. And then one time you measure the temperature, and the temperature's way up here. Odds are that's a calculation error. Okay, can't throw it out. Now, if you can prove it's a calculation error, like your thermometer is broken or something weird happened, then you can say, okay, forget that. Let me just retest, right? But if you can't and you just get a bunch of data, a lot of times something like this, an outlier, could just be a problem with measurement. Okay, so that's why we throw out outliers, not because they're necessarily super good or super bad and they mess things up. Okay, so that's your box and whisker plot. The only other thing is the IQR here. That's interquartile range, which sounds confusing, but all that it really means is this. Here, what we have here was 14, right? And here was 24. So here was 14, here was 24. Okay, forget that. First quartile was at 14, third quartile was at 24, and the interquartile range is what's the gap between these two? What's the range? Remember what range is? Range is the top data to the bottom data. So the range for all the data here would be 27 minus 12. Okay, so the max minus the min is 15. Okay, so the difference between top and bottom that's your range, how spread out the data is. The interquartile range is, okay, from the first quartile to the third quartile, how much room do I have? And 24 subtract 14 is 10. That's the interquartile range. Okay, so what do we get from that? What's going on with these box and whisker plots? Well, first of all, let me just show you one thing. Here is these scales 10 to 30 and that sort of thing. Once we're done, we can kind of ignore them. Okay, so don't compare to this because I just kind of randomly did this here. Just because there's a big gap here between the end of the whisker and the 30 doesn't mean anything. Okay, so you can kind of ignore, once you have it drawn, you can kind of ignore the whole scale. But let's go back to our note here, your class note, the content, and if I can get to it. Yep, and we'll talk about what happens when you have a certain box and whisker plot, what that means. So here, this is called symmetrical data. Symmetrical data, this is super symmetrical, right? Because you have a box like this and just little whiskers, and you have the median in the middle here. Okay, so our data was somewhat like that, but if you go back to where we were, where was that? How did I get to this? You'll notice that pretty simple, pretty similar, right? The whiskers are like this, but the median is way over here. So you're gonna have more people, okay, on this side of this box here. Okay, so you're gonna have if we showed a distribution table, or not a table, a graph, you're going to have more people over here by the median, okay, and less people over here. It's going to kind of drag the median over, okay, so it'd be something like this and then down like that, okay, and then you have your extremes like that, okay. So ours is kind of symmetrical. It would be more symmetrical if the median was in the middle, okay. If you get the whole thing pulled over to one side or the other, okay, so the whole box and whisker plot pulled over. So let's do this. Give me 1 second. Let me go back here. So here you have what's called negatively skewed, which is kind of what we had. Okay, we had it kind of pulled over to the the median was a bit here, but this whisker was not that long. So what we had was a little bit negatively skewed. Here, when you have a long whisker on this side, you could have what's called positively skewed also, and that's technically defined here by the size of the whisker. Okay, everything's a little, but if you look at our situation, so this is where it gets a little messy, is you don't necessarily have something that's positively skewed or negatively skewed. A lot of times this is just kind of your opinion, and you look at this sort of thing and you say, okay, this kind of looks that way, this kind of looks that this way. So if we go back here, this was what, 14, this was 12, okay, and this was 24, and this was 27. So the whiskers are the same size. Okay, so we had something that looked like this. We actually had a short whisker here, a skewed median over on this side, and a slightly longer whisker here. So how is this skewed? I don't know. Is this symmetrical? It's really your opinion. Okay, so this whisker is longer. You could say it's skewed to the right here, but you could also say, look, the median's on the left. So when you look at the two different examples we did here, with the median here, on the left, this is negatively skewed. Okay, you get kind of pulled over this way by this stuff. But when you have the long whisker here, this was positively skewed. So how would I define that data I just did? I don't know. It's pretty symmetrical, I would say. Okay, maybe a little bit negatively skewed, maybe a little positively skewed. Okay, so again, it's not. this is an interpretation of what you see. And a lot of times things like this will be good, sometimes it won't be good. Okay, it's the same with mean, median, and mode. Sometimes the mean tells you the data, sometimes the mode tells you about the data, and this is just another way to look at distribution. Okay, so I know it's a little confusing and maybe not giving you the exact answers that you want, but the truth is this doesn't give you exact answers. It just gives you a way to look at the data. Okay, hopefully that helps. Try one or two of the homework questions. Send me an email if you'd like, and have a nice day.